Now let me talk about some of the properties of the indifference curve. Let me first make up the indifference curve that we had made previously. This is my x and this is my y. We had taken the biscuits on x-axis and chocolates on the y-axis, and we got a curve like this. So the first property of the indifference curve is that an indifference curve is downward sloping to the right. Now, why is this indifference curve downward sloping to the right? I have already talked about this because it is because of the falling marginal rate of substitution, which means that as I have more and more of this commodity, as I am having more and more of the biscuits, I am going to give less and less of the chocolates. Having more and more of these biscuits, I am going to give less and less units of the chocolates. So this is the reason why the MRS is downward sloping to the right, which means that having more and more of the biscuits, I am going to give less and less units of the chocolates. So this is the reason why marginal rate of substitution is falling, and this is the reason why indifference curve slopes downwards to the right. Now let me talk about the second basic property, that is indifference curves are convex to origin. Now, if we see to the origin, these are convex. The convexity of this indifference curve is because of the firstly because of the falling MRS, and secondly because of the imperfect substitutes. Had these biscuits and the chocolate being the perfect substitutes, then we would have got the indifference curve that would have been a straight line. It is only because of the imperfect substitutability between the biscuits and the chocolates we get the indifference curve that is always convex to the origin. Had these goods been the perfect substitutes, then the indifference curve would have been a straight line. Now let me talk about the third this property. Now the third difference property says that indifference curve never intersect each other. Now the two indifference curves are never going to intersect each other. Let me explain this. Say for example, we have this one intersect here, we are taking the biscuits, and here we are taking the chocolates. If we have the indifference curve 1 and we have another indifference curve like this, indifference curve 2, they are intersecting at point A, say for example, which means at point A the point A contains the same commodities as that of the indifference curve 1 and in that of the indifference curve 2, which is not possible because higher indifference curve contains higher amount of the commodities. So higher indifference curve contains higher commodities, which is actually true if you look here. So if we see here, indifference curve 1 has only this amount of the commodities, while its indifference curve 2 has more. Say for example, this is 5, so this is 6 and this is 7. So over here it has more commodities as compared to the indifference curve 1. Indifference curve 1 contains only 6 biscuits, whereas the indifference curve 2 contains 7 biscuits and 5 chocolates, which means that the higher indifference curve contains the higher level of the commodities. So the two indifference curve can never intersect each other. The fourth assumption, or the fourth property of the indifference curve says the same thing, that is the higher indifference curve represents higher level of satisfaction, which is definitely true. Now let me write it down. The higher indifference curve represents higher level of satisfaction. Now let me make up the indifference curves for you. Let me talk about what these indifference curves mean. This is the chocolate. Now this is my indifference curve 1. I draw parallel indifference curves. This is a set of these indifference curves. They are set of ICs. They are known as indifference map. Now see, what I mean by the higher indifference curve represents higher level of satisfaction, which means that essentially because the higher indifference curve contains more commodities as compared to the lower indifference curve, so the satisfaction is going to be more in the higher indifference curve. Now let us consider a case here. Say for example it contains 3 units of chocolates and 2 units of biscuits. At the same time, the higher indifference curve 2 contains 3 units of the chocolates, but it contains 3 units of the biscuits. So over here the total commodities are 5. In this the total commodities are 6. If we move on over here, though it is 4, let me consider this is 4. So in the indifference curve 3 there are 7 commodities in total, which means that if there are more commodities there will be more satisfaction. So higher the commodities, higher the indifference curve, higher is going to be the satisfaction. Now the last point, that is indifference curve does not touch axes. Now this is very easy to remember and to understand. And we have chocolates and we have this y over here. Now suppose this indifference curve starts from here. Now let me use another color here. Suppose we get an indifference curve like this, which essentially means that over here I have the 0 units of biscuit, and over here I have 0 units of the I have 0 units of biscuits, and over here I have the 0 units of chocolates, which essentially will not be the case, because in indifference curve we at least have 2 commodities. So these points are not possible for the indifference curve analysis, because at least one of the commodity, at least 2 commodities need to be present. Even if the second commodity is just 1 unit, it needs to be present in the combination. Otherwise, it will simply become a one commodity case that is studied under the marginal utility analysis that we have talked about in the previous lectures. So because of at least the one commodity being present, it never touches the any axis, neither the x-axis or the y-axis. That's why it starts. It does not touch any of the axes, that is x and y, because it means that neither of the combination has a 0 of the one commodity in the combination.